In September 1924, the French company Farman rolled out a new variant of their well-known F.62 aircraft. They equipped this version with powerful Lorraine-Dietrich 12 dB engines. These engines produced 400 horsepower each. Initially, they built at least 3 civilian aircraft with this power plant. Each one took on a unique role. The first airplane was converted into an air ambulance. They outfitted the cabin with 12 stretchers for wounded soldiers. It also had seats for a doctor and an orderly. They decided to turn the second aircraft into a dedicated bomber. Meanwhile, the third example was sold to Czechoslovakia. Later on, 2 more F-62s with those same engines were assembled for the French Air Force. Interestingly, they were built using unfinished passenger airframes. But when the first prototype underwent testing at Cazaux Air Base, the military came to a disappointing conclusion. These aircraft were completely unsuitable for actual combat operations. Because of this, they decided to turn them into flying classrooms to train future navigators. However, the military career of these airplanes turned out to be short-lived. By September 1924, they had already been sold off to private owners. Stripped of all armament, both F-62s spent the rest of their days peacefully hauling mail. One of the most interesting developments of the twin-engine Goliath was a special record-setting F-62. This was a single-engine biplane. It shared much of its design DNA with its larger twin-engine predecessor. This airplane was created with one specific goal in mind. That goal was setting world records. That's exactly why, from day one, engineers built in massive auxiliary fuel tanks. They also chose a reliable Farman-built engine to power the aircraft. Their hard work paid off. On July 16th and 17th, 1924, this F-62 was flown by experienced pilots Lucien Coupé and Maurice Drouhin. It set 2 world records at once. One was for closed circuit distance and another for flight duration. The aircraft stayed continuously in the air for almost 38 hours. It covered over 1,242 miles along the Champol to Chartres to Champol route. In the first half of the 1920s, the military leadership of the Soviet Union was actively looking to develop their own heavy bombers. However, they lacked the industrial base at the time. So as a stopgap measure, the government decided to buy a few foreign models. The Soviet military ultimately settled on the F-62. This aircraft stood out primarily for its low cost and ease of maintenance. It also used readily available materials. For a developing nation at the time, it seemed like the perfect option for daily operations and potential reverse engineering. Driven by that same cost-saving logic, they selected 450 horsepower Lorraine-Dietrich 12 EB engines for these airplanes. These engines were excessively heavy, poorly balanced, and notorious gas guzzlers. Even so, their low price tag outweighed all the downsides. On top of that, they were planning to use these exact same French engines across their fleet. They wanted to install them on Soviet R-3 LD reconnaissance aircraft and Dornier Wal flying boats. These were locally designated as the DV. In total, they ordered just 4 of these aircraft. All the paperwork was handled through the Soviet embassy in Paris. The People's Commissariat of Foreign Trade acted as the official buyer. To ensure the aircraft could be easily maintained, the order included the necessary tooling. It also included a basic set of spare parts and specialized hoists with winches for assembly in the field. The financial deal was split into 3 equal installments. A third was paid up front as an advance. Another third was released after the aircraft were loaded onto a ship. The final payment was made once the cargo arrived in Leningrad. Staff from the trade mission and air attaché Leonid Grigorovich Minov closely monitored the process. This ensured the order was completed to spec. Externally, the Goliaths purchased by the Soviet Union looked very similar to the aircraft Poland had ordered earlier. They featured the same spacious side-by-side cockpit for the 2 pilots, along with that distinctive nose section with a balcony on top. The engines were different, however, and 2 powerful landing lights were mounted on the sides, right below the balcony. Knowing full well just how rough Soviet dirt airstrips could be, the buyers insisted on fitting special reinforced wheels. Additionally, they equipped the bombers with radios featuring a direction finder and a loop antenna. This setup allowed the crew to navigate using commercial broadcast stations as radio beacons. On these variants, designated as the FG-62, the plan was to mount 4 machine guns. But the French factory only installed the mounting brackets. the design completely omitted a ventral gun position and a fifth machine gun. However, the French-style bomb racks and release mechanisms were installed right from the factory. A bomber of this type was meant to be flown by a crew of 5. The crew included 2 pilots, a navigator bombardier, a radio operator, and a flight engineer. In Soviet military documentation, these aircraft were designated as the FG, FGLD, or F.62. Preliminary inspection and acceptance of the finished bombers took place directly at the Farman plant in Billancourt, France. That is also where the aircraft made their initial test flights. In mid-August 1925, Soviet representatives signed all the necessary acceptance paperwork. After that, the brand new bombers were carefully disassembled and transported by sea to Leningrad. The order was considered so critical that the head of the Air Force Directorate, Pyotr Ivanovich Baranov, personally traveled to France to accept the equipment. To avoid drawing unwanted attention, he arrived undercover, posing as an ordinary engineer named Petrov. Naturally, intelligence agencies around the world kept close tabs on high-profile figures like him. But the tactful French pretended not to notice. Still, when it came time to see Pyotr Ivanovich off at the train station, the French Minister of Aviation himself showed up with his entourage, though they all wore civilian clothes to play along with the charade. Meanwhile, back in the Soviet Union, there was serious talk about simply reverse engineering the French Goliath and putting it into serial production without a license. In early December, during a meeting of the Aviation Technical Committee, they had to settle a key question. Should they just build a direct copy of the FG-62 bomber, or would they be better off designing their own aircraft around those exact same engines? The strongest argument for the first option was just how structurally and technologically straightforward the French aircraft was. But renowned aircraft designer Nikolai Nikolaevich Polikarpov pushed back against this. He explained that copying the Farman aircraft would take anywhere from 14 to 16 months. In that same time frame, they could easily design a similar aircraft much better suited to the actual needs of Soviet aviation. Ultimately, the leadership decided to build their own biplane bomber. They took the FG-62 design as a baseline, but scaled it up for significantly more powerful engines. By that point, Polikarpov had already drawn up a design for this type of airplane powered by M5 Liberty engines. He later adapted it for Lorraine motors and eventually for the upcoming Soviet M14 power plants. During development, the bomber's upper wing was moved slightly forward, turning the design into a sesquiplane. Construction of the final version, equipped with German BMW-6 engines, began in 1929 under the designation TB2. By then, however, practically nothing of the original French Goliath remained. Since the highly anticipated German JUG-1 bombers were facing constant delays, new negotiations began in France in July 1926 to buy another batch of Goliaths. Initially, they planned to purchase 13 aircraft. However, they eventually settled on just 10. Farman promised to fulfill the order completely within a year of signing the contract. Soviet representatives were allowed to choose engines from any French manufacturer, though Jupiter engines were highly recommended. Noam Rohn, who built them, even offered a joint contract with Farman. They had already lined up a favorable 18-month bank loan. Just like before, the French promised to send 3 of their mechanics to the Soviet Union to oversee assembly. They also promised to host 2 Soviet pilots for training. That summer, on July 24, 1926, the chief of the Air Force, Pyotr Ivanovich Baranov, made a request. He asked the Revolutionary Military Council to allocate 70,000 gold rubles per bomber for the deal. His proposal was fully supported by the council's deputy chairman, Yosef Stanislavovich Unschlicht. In late October, by direct order of the head of government, Alexei Ivanovich Rykov, a substantial sum was allocated to the Air Force. This amounted to 3 million rubles in foreign currency. But right at this stage, things suddenly ground to a halt. Maybe Junkers offered much better terms, or perhaps the French were fundamentally unhappy with something during negotiations. Whatever the case, the Soviet military ultimately bought the German JUG-1 aircraft instead. The story of buying the French Goliaths ended right there. Technically speaking, the FG-62 was a classic day and night bomber. It was a wooden, twin-engine biplane designed for a 5-man crew. Its wings were strictly rectangular, maintaining a constant chord along the entire span. The upper and lower wings had an identical span. They were mounted directly on top of each other with zero stagger. The upper wing consisted of a center section and two easily detachable outer panels. The wing structure itself was built around robust wooden spars and wooden ribs. For extra rigidity, internal cross-bracing cables were tensioned between these components. A wire ran along the trailing edge of the wing. It pulled the fabric taut and gave it a characteristic scalloped appearance. The leading edge was skinned with plywood, while the rest of the surface was covered in aviation fabric. This fabric was carefully stitched to the ribs. All the seams were taped over with fabric strips to reduce drag. The center section of the upper wing, meanwhile, was mounted above the fuselage on heavy-duty cabin struts. The lower wing shared a similar structure with the upper one, but its center section attached directly to the fuselage. The upper and lower wings were connected by 3 pairs of sturdy struts on each side. Interestingly, the inboard struts rested right on the massive engine nacelles. To maximize structural integrity, each strut bay was cross-braced with steel cables. Underneath the lower wing, near the outboard struts, engineers installed protective wingtip skids. These were firmly secured with bracing wires. Overall, this entire biplane structure formed a rigid box. It was heavily reinforced by a complex web of rigging wires. The cabane structure supporting the upper wing above the fuselage consisted of 4 struts. These were tensioned with longitudinal and transverse bracing wires. For flight controls, ailerons were fitted to both the upper and lower wings. They featured a simple but proven design. This consisted of a wooden frame tightly covered in doped aircraft fabric. The control mechanism was actuated by a series of bell cranks. To ensure the upper and lower ailerons moved in perfect sync, they were linked by strong interconnecting cables. The fuselage of the legendary Goliath had a classic rectangular cross-section. Just ahead of the cockpit, the upper decking curved up into a distinct hump. The backbone of this structure consisted of 4 massive wooden longerons running the entire length of the aircraft. These were tied together by vertical and horizontal crossmembers. Internally, the fuselage was divided by transverse bulkheads. Constructed of plywood-skinned wooden frames, these bulkheads separated the interior into distinct compartments. One was right behind the navigator's station. Another was just ahead of the radio operator's position. A final one was back in the tail section. To prevent torsional twisting under vibration, the wooden airframe was heavily cross-braced with tension wires. The entire exterior was skinned in plywood. In the rear section, wooden stringers were nailed along the sides for added rigidity. Now let us take a look inside. In the aircraft's rounded nose, right underneath that hump, sat the navigator's station. Directly above it was a forward machine gun ring to fend off enemy fighters. To give the navigator a clear view of his surroundings, the nose was fitted with front and side windows. It also had a dedicated floor hatch for operating the bomb sight. The roof featured another hatch with outward opening split doors. Moving just aft of the navigator's station brought you to the flight engineer's compartment. From there, a ladder led up into the open cockpit. The pilots sat side by side with nothing but a shared windscreen to protect them from the brutal slipstream. They sat on stiff wooden seats. Crazy as it sounds by today's standards, the designers did not even leave room for emergency parachutes. Heading further aft, a walkway led to the radio operator's station. His radio gear was bolted directly to the portside bulkhead. Further aft in the tail section was a raised platform where the gunner manned the rear machine gun. The entire crew boarded the aircraft through a single door on the starboard side of the fuselage. The aircraft's tail section featured a fairly conventional layout. The horizontal stabilizer was built as a single, one-piece structure mounted directly on top of the fuselage. It consisted of a wooden frame reinforced with internal wire bracing and tightly covered in fabric. The triangular vertical fin shared the same wood and fabric construction, as did the flight control surfaces. Notably, the rudder featured an aerodynamic horn balance. This helped to reduce the control forces required for pilots to wrestle this massive airplane around. The main landing gear utilized dual-wheel bogies with wire-spoked wheels. Their sides were protected by smooth aluminum wheel covers. Initially, the airplane rolled on 800 by 150 mm Palmer rubber tires. later swapped out for slightly wider 800 by 160 mm Dunlops. The wheels sat on a common axle supported by steel struts tied directly into the lower wing structure. Suspension was handled by classic rubber bungee shock absorbers rather than complex hydraulics. Both the left and right landing gear struts were wrapped in fabric and braced to the wing with double flying wires for extra strength. Out back, a simple wooden tail skid used a rubber bungee cord to absorb landing impacts. For winter operations, ground crews could swap each pair of main wheels for a single wide wooden ski. They could also fit a miniature ski to the tail skid. This particular F.62 modification was powered by a pair of Lorraine-Dietrich 12 EB engines. These were reliable, water-cooled W12 engines. Each was pushing out a maximum of 450 horsepower. They were mounted in nacelles just above the lower wing and carefully enclosed in cowlings hand-beaten from sheet aluminum. The aviation fuel and oil tanks were also tucked away inside these nacelles. This kept them safely isolated from the crew. Exhaust from each cylinder bank fed into a separate manifold. It was routed through a long pipe extending to the rear of the nacelle. This channeled exhaust gases clear of the aircraft. Andre honeycomb radiators were strut-mounted directly above the engine nacelles. They featured distinctive hexagonal tubes. Each unit was split into two separate sections to optimize cooling. Two classic Levasseur, two-blade wooden propellers provided the thrust. Their leading edges were sheathed in copper to protect against debris strikes. Engine starting was handled either by an external mechanical starter that engaged with special hooks on the propeller hub. It could also be done via the standard Viet pneumatic starting system. The fuel system relied on riveted metal tanks strapped securely inside the engine nacelles. Small, wind-driven external pumps supplied fuel continuously to the engines. The oil tank sat right behind the engines, filled with the castor oil that was so common in early aviation. When fully fueled, the combined weight of the fuel and oil came out to about 2,557 pounds. The aircraft featured dual controls, allowing it to be flown by either the pilot or the co-pilot. It relied on a conventional control system made up of cables and pulleys. Both pilot stations were equipped with standard yokes and rudder pedals. The main instrument panel right in front of them housed the essential flight instruments. These included a basic navigation suite, a clock, and two reliable Vion compasses. Interestingly, the engine gauges did not fit on the main panel. Instead, they were mounted outside the cockpit down on the interplane struts, directly above the engines. To communicate over the deafening roar of the engines, the crew used a primitive intercom system. This consisted of basic rubber speaking tubes. These allowed the pilots to talk back and forth with the observer, the mechanic, and the radio operator. For its time, this airplane boasted a surprisingly complex electrical system. It was divided into two separate circuits running at different voltages. These were 24 and 40 volts. Power was supplied by two engine-driven Vaucanson generators. They put out 500 watts each. In addition, a Levasseur wind-driven generator was mounted on the lower left wing near the fuselage. Driven by a small propeller, it produced current directly from the slipstream during flight. The aircraft also carried a battery bank of 9 accumulators. Thanks to all this electrical power, the cockpits featured interior lighting and even a planche electric heating system. This was quite a luxury at the time. For night landings, the pilots relied on two powerful Barbier-Bénard landing lights mounted on the nose of the fuselage. They also used special Michelin pyrotechnic flares. These flares were electrically triggered to brightly illuminate the runway. For communications, the F.62 was equipped with a two-way radio capable of both voice and Morse code. To use it in flight, the crew would reel out a long, trailing wire antenna. The radio also featured a direction-finding attachment. This included a movable loop antenna tucked underneath the observer's cockpit. For reconnaissance missions, a Laberly vertical camera was mounted inside, taking pictures on heavy glass plates. The designers also kept safety in mind. The fire suppression system featured Hermann Eckler extinguishers mounted directly on the engines. It also included a portable Le Feline extinguisher inside the fuselage in case of a cabin fire. The bomb load was carried externally. 7 bomb racks were mounted underneath the forward fuselage, neatly arranged in 2 rows. There were 4 in the front and 3 in the rear. The bomber typically carried around 575 kilograms of ordnance. This usually worked out to 7 standard bombs. The maximum payload could actually reach over 1,050 kilograms. But to hit that mark, the aircraft had to be loaded with heavy 150-kilogram French bombs, which the Soviet Union simply didn't have in its arsenal at the time. The bomb release mechanism itself was fairly straightforward. A mechanical system with 7 individual release levers sat to the right of the observer. A dedicated control box with 7 indicator lights hung on his left. These lights would go out one by one, confirming that a bomb had successfully dropped and was on its way to the target. To fend off enemy fighters, the aircraft packed some respectable defensive armament. This consisted of 2 ring mounts, each fitted with twin 30-caliber Lewis machine guns. The guns were fed from their distinctive top-mounted pan magazines. Spare magazines were conveniently stowed in dedicated racks on either side of the gunners. They were strapped down tightly with leather belts so they wouldn't go flying around during hard evasive maneuvers.